When the space age began, there was no such thing as a graphical user interface. Astronauts interacted with their electronics using only knobs and toggle switches. It was a different time. Fast forward to 2015. The knobs and switches of the 1950s have been replaced by a glass cockpit where the majority of commanding is done through software controls. Old-fashioned twisting and flipping may soon be replaced by a complex combination of taps, swipes, and fingertip swirls. Many tasks performed inside a modern spacecraft will involve fine motor skills such as typing or interacting with a computer touchscreen, says Christina Holden, principal investigator for the Fine Motor Skills experiment now underway on the International Space Station. In the future, astronauts will use portable computers for many tasks, including maintenance, training, medical treatment, science, timelining, and scheduling. It is well known that microgravity can have a detrimental effect on the human body. Muscles atrophy, bones weaken, and the immune system doesn't function properly. Are fine motor skills affected as well? The Fine Motor Skills experiment aims to find out. We really haven't seen problems, but this type of performance hasn't really been measured systematically in space, says Holden, who works for Lockheed Martin in Houston, Texas. Some experiments have shown that tasks take longer in microgravity than on the ground, but no study has yet looked at the type of tests that are included in this investigation. The Fine Motor Skills experiment studies the effects of long-duration microgravity on the type of fine motor task performance required to interact with computer-based devices, such as tablet computers with touchscreens. Crew members will complete 4 types of tasks on an iPad: pointing, dragging, shape tracing, and pinch rotate. Our real concern is making sure that future crew members can use their computer-based devices with accuracy on board and on a planetary surface after a long voyage, for example, to Mars. Imagine what might happen if faulty finger work prevented an astronaut from accurately checking the life support system on a future spacecraft. If we find performance deficits in this long-duration study, we may need to develop some exercises or practice tasks to keep fine motor accuracy high, explains Holden. This experiment could also benefit people on Earth. Holden believes that if the Fine Motor Skills test battery works well for measuring astronaut performance in space, it might also be a great tool for measuring performance back home. For example, it could be used to see how much fine motor performance a Parkinson's or brain injury patient has lost compared to a healthy person. It may also be that one or more of these tasks, if performed frequently, could serve as a fine motor rehabilitation tool. The team was recently contacted by a university occupational therapy department interested in working together to develop some of these ideas. For more news from Earth orbit, go to www.nasa.gov/station. And for more science news at your fingertips, visit science.nasa.gov.